We will now be doing a problem based on Born-Haber cycle. I had explained earlier also one example of sodium chloride, how to find the lattice energy. Let us take one more example, that is formation of magnesium iodide. So how do we start? Let us read the question. That's the best way to start. Calculate the lattice energy of magnesium. That is the aim. From the following data, you are given enthalpy of sublimation of magnesium, that is magnesium solid is becoming magnesium direct vapor, sublimation. Enthalpy changes 150 kilojoule per mole. First ionization enthalpy is 738, second ionization enthalpy is 1450 kilojoule per mole. Enthalpy of sublimation of iodine is given. Enthalpy of atomization is given. Enthalpy, electron gain enthalpy of iodine is given, and enthalpy of formation of magnesium iodide. That is where we start the story. We take this point. What do we have? Enthalpy of formation of magnesium. What does the definition of enthalpy of formation say? 1 mole of the substance. Which is the substance? Magnesium iodide, solid. 1 mole of the substance is formed from the elements in the standard state. So at room temperature, magnesium is a solid, iodine is a solid, and it forms magnesium iodide solid, 1 mole. Okay. And this delta formation H is minus 430 kilojoule per mole. Is minus 430 kilojoule per mole. Now, how do we use Born-Haber cycle? See, magnesium solid becomes magnesium gas. So this is delta sublimation H. And how much is that given? Enthalpy of sublimation is, I'll write it on this side so it becomes easy. We can use. So we have delta sublimation H is equal to how much? It is 150 kilojoule. Then magnesium is forming magnesium plus in the gaseous state. This will be what? First ionization enthalpy. So delta ionization enthalpy H1, how much is it? It is 738 kilojoule. Then we have magnesium plus forms magnesium plus 2. So this is delta ionization enthalpy H2. That is how much? 1450 kilojoule per mole. 1450. So this is in the gaseous state. Then we look at situation for iodine. Now iodine is clear. Solid is becoming iodine gas, vapor. So this is delta sublimation H for iodine, and that is given as 151 kilojoule per mole. Then iodine is breaking into its gaseous atoms. So you have 2 iodine atom. This is enthalpy of atomization. That is, so delta atomization H will be equal to 150 kilojoule per mole. Now this iodine atom is becoming 2I minus gaseous state. So this is twice into electron gain enthalpy, because electron gain enthalpy is for 1 mole, but 2 moles of iodine atom. So that will be 2 into how much? Minus 295, 2 into minus 295 kilojoule. Now Mg plus 2 in the gaseous state plus iodide ion in the gaseous state, this forms magnesium iodide. This is delta lattice energy H. Okay. So what do we have? This value should be equal to this plus this plus this plus this plus this plus this plus this. So what do we have? So we have delta formation H is equal to delta sublimation H plus delta ionization enthalpy H, first one, plus delta ionization enthalpy H2. All this is for magnesium. Barabar? Plus what will you have? Delta sublimation H plus delta atomization H plus 2 into delta electron gain enthalpy H plus, so this is for iodine, this is for magnesium, this is for iodine. Plus delta lattice energy H. So that total should be equal to how much? So this whole thing, I think I have another color pen. 1 minute. Oh yeah, I have it in my pocket. So this whole thing is equal to delta formation H. So what do we have? So minus 430 is equal to how much? This minus 430 yeah, now it is correct. So minus 430 is equal to plus 150 plus 738 plus 1450 plus 151 plus 150 minus, so 2 into 295, how much is it? 400, 300, 600, 600 minus is 590. So we have 295 into 2 will be 590. So minus 590 plus delta lattice energy H plus delta lattice energy H. Yes, you can see it. So let me calculate this first and take it on this side. So what do we get? We have 150 plus 738 plus 1450 plus 151 plus 150. So that is 2639 minus 590. So 2049. So plus 240. So what do you get? This will be minus 430 minus 2049 will be delta lattice energy H. So how much does the total become? So we have plus 430. So 2479. So this becomes, so delta lattice energy H becomes minus 2479 kilojoule. Now we are going to be doing problems based on thermochemistry and Hess's law. So you can see in this sum, the sum says calculate the heat of the following reaction. Okay, at 298 Kelvin, 2 moles of nitrogen dioxide forms 2 moles of nitric oxide plus oxygen. So in this case, the formula that we are going to use is delta H, the enthalpy change, is equal to summation of the enthalpy of product minus summation of enthalpy of reactant. This is clear. So here one rule that we are following is what? Enthalpy of any element or in any substance, the elemental state is taken as 0. It is not 0. It is taken as 0. This is the difference between enthalpy and entropy. You are assuming it to be 0, whereas in entropy we have the value. When is it 0? At pure crystalline state at 0 Kelvin. This is clear. So here what happens, therefore delta H is equal to enthalpy of product is 2 into enthalpy of what? NO minus, I am not taking O2 because O2 is considered to be 0, minus 2 into enthalpy of NO2. But what is the enthalpy of any compound? Enthalpy of element is taken as 0. But what will be the enthalpy of any compound? Enthalpy of any compound is its heat of formation. Is its heat of formation. So that is given. So delta H therefore becomes equal to 2 into enthalpy of NO. So enthalpy of NO is given as 2 into 90.72 minus 2 into, what do we have? Enthalpy of formation of NO2, that is 33.98. So what do we have? Simple. The answer will be 90.72 minus 33.98 into 2. So therefore delta H, the enthalpy change will be plus 113.48 kilojoule. So this is how you find the answer to this sum. This is one way of finding out the answer to the sum. So what have you understood over here? 2 points in this sum. Enthalpy of elements is taken as 0. Enthalpy of the compound is not mentioned. Instead, what is mentioned is its heat of formation. So enthalpy of formation is the enthalpy of the compound. And what is the enthalpy change? It is the summation of the enthalpy of product minus enthalpy of reactant. Okay. This is a very common question in any board exam. Find the heat of formation of ethyl alcohol from the following data. The heat of combustion of carbon is minus 395.5 kilojoule. Heat of formation of water is minus 285.77 kilojoule. Heat of combustion of ethyl alcohol is minus 1376 kilojoule per mole. So all these are in the statement form. We have to convert it into the equation form. Okay. So what we have is the required equation. So what we'll do is, how will we do it? So what we have over here is, see, the required equation is, that's the first step. The required equation is, that we'll get from the question. Find the heat of formation of ethyl alcohol. So what is the required equation? Heat of formation of ethyl alcohol. What is heat of formation definition? 1 mole of ethyl alcohol is formed from the elements in the standard state. So what do we have? We have 2C carbon solid plus 3H2 gas plus half O2 gas. So carbon element, hydrogen element, oxygen element in the standard state is forming 1 mole of ethyl alcohol. So from the given data, by addition, subtraction, reverse, whatever it is, you have to get this equation. And then the same exercise has to be done with the delta H values. So A, what do we have? Heat of combustion of carbon. So what does the definition say? Heat of combustion of carbon is 1 mole of carbon is burning in excess of air, and when carbon burns in excess of air, it forms carbon dioxide gas. So here the delta H1 is minus 395.5 kilojoule. B, heat of formation of water. So what is heat of formation? 1 mole of water, I am using the definition every time. 1 mole of water is formed from the elements, so H2 plus half O2. So H2 gas, half O2 gas. So this delta H2 they have given us equal to how much? It's minus 285.77 kilojoule. Then C, your heat of combustion of ethyl alcohol. So what is heat of combustion? 1 mole of ethyl alcohol, okay, liquid, burns in excess of air or oxygen to form carbon dioxide gas plus H2O. Let us balance it. So how many carbon do you have over here? 2. So this is 2 CO2. How many hydrogen you have? 5 plus 1, 6. So this is 3 H2O. So how much of oxygen you require? 2 2s are 4, 4 plus 3 7. 7, here already there is 1 over here, 6. So you need only 6 O2. So this is 3 O2. So this is the balanced reaction for heat of combustion of ethyl alcohol, and delta H3 is equal to how much they have given the value? It is minus 1376 kilojoule. Now what happens is, these are the values which we have converted from statement into an equation form. And what do we require? We require this equation. So now we have to do some changes over here. So this is the delta H value we have to find out, okay? So how will we get delta H value? Delta H will be equal to, look at the equation. In the given equation, you have 1 mole of carbon, but you require 2 moles. So what we do? Delta H will be 2 times delta H1. In the given equation, you have 1 mole of oxygen will take care of itself. You have 1 mole of H2, but you require 3 moles of H2 plus 3 times delta H2. Oxygen, I said, will take care of itself. What you have over here is ethyl alcohol. You have 1 mole of ethyl alcohol on the product side. You have 1 mole of ethyl alcohol here on the reactant side. So if the reaction in the forward direction is exothermic, in the backward direction it is endothermic. Laplace-Lavoisier law. So minus delta H3. So if we do these mathematical operations, we should get the required equation. Let's try. So now we have DEF. So first reaction we multiply by 2. So we have 2C plus 2O2 forms 2CO2. E, 3 times delta H2. So 3H2 plus 3 by 2 O2 forms 3H2. F. We are absolutely reversing the whole thing. So you have 2CO2 plus 3H2O forms what? C2H5OH plus 3O2. Now you see over here, two CO2 gets cancelled with 2 CO2 over here. 3H2O gets cancelled over here. 3 moles of oxygen, and this is 3.5. So what is left is half O2. Half moles of O2. So what we realize is that if you add, you get this reaction only. 2C plus 3H2 plus half O2 forms C2H5OH. So now having confirmed, now we'll do the same thing with the delta H values. So what is it that we have? Two times delta H1. So delta H will be equal to 2 into minus 395. 3 times delta H2 plus 3 into minus 285.77. And this minus 1376 will become plus 1376. Will become plus 3 plus 1376. So therefore your delta H will be equal to what? 395. So it will be 395 into 2. So that is minus 790. 3 into 285.77. So that is minus 857.31 plus 1376. So plus 790. So that is 14. So delta H will be minus 1647.31 plus 1376. So I will therefore have 1376 minus 1647.31. So this value, so delta H value will be minus 271.31 kilojoule per mole. So this is how we get an answer to these kind of sums. I will highlight the answer. Is this clear? Now let us look at the third sum. Calculate the heat of formation of methane from the following data. What do we have? See, methane, CH4, the first equation that they have given is heat of combustion of methane, because 1 mole of methane is forming carbon dioxide and water. So whenever any hydrocarbon burns in air, it is supposed to form only carbon dioxide and water. It's supposed to form only carbon dioxide and water. Then what do we have? This is heat of combustion of carbon, and this is heat of formation of water. Why? Because 1 mole of water is formed from the elements in the standard state. So what do we have now? The required equation. So we have to get our required equation from what? From the statement in the question. So we have the required equation is What is the statement? Calculate the heat of formation of methane. Heat of formation means what? You have 1 mole of methane forming from the elements in the standard state. Which are the elements? We have carbon solid plus 2H2 gas. This is the reaction from the definition, and we have to find the delta H of that. So how will we get delta H? Let's first write the equation combination, and then we will come to it. It's always better to write this way in the board. See, for getting delta H, let us look at the value. The first equation, you have methane on the reactant side, but in the required equation you have 1 mole of methane in the product side. So minus delta H1. So you are reversing this equation. So methane goes on the product side. You require 1 mole of carbon, you have 1 mole of carbon plus delta H2. You require 2 moles of hydrogen, you have only 1 mole of hydrogen over here plus 2 times delta H3. Don't worry about others, they will cancel each other. So now we have, look at the fourth equation, we are going to arrange as per this. Minus delta H1, so what do you get? You have CO2 gas plus 2H2O liquid forms what? CH4 methane plus 2O2 gas. Okay, we'll see the delta H values afterwards. Now the fifth, second equation has to be written as such. So we have carbon solid plus O2 gas forms carbon dioxide gas. Okay. Sixth equation, 2 times delta H3. So you have 2H2 gas plus 2 by 2 means it is O2. Gas forms 2H2 liquid. So having rearranged, let us see what are all that is getting cancelled. So you have 1 mole of carbon dioxide cancelling with 1 mole of oil. Then you have 2 moles of oxygen cancelling with this 1 mole, 1 mole, 2 mole. 2 moles of H2O getting cancelled over here. So what is left out of all this? You have C plus 2H2 forms CH4. That's the required equation. So now we do the same mathematical operations. So what do we have? So delta H will be equal to minus delta H1. So this becomes plus 928.842. Then we have delta H2 as such minus 395.5 plus 2 times 2 into minus 285.77. So let us now calculate this. So what do we get? 285.77 into 2 plus 395.5. So 967.04. So we have over here, listen, this is delta H is equal to plus 928.842 minus 967.04. So 967.04 minus 928.842. So you get the value plus. So this will be, which one is greater? 967. So this value will be minus 38. This will be So delta H value therefore will be minus 38.198 kilojoule. Let's check the answer once again. So what do we have? We have 3, this is okay, 2 into 285.77 967 minus 928. $38.19. Okay. We come to the fourth problem on. Now in this problem we have heat of, again everything is in the statement form and we have to convert it into equation form. Is this clear? What we have is heat of formation of sulfur dioxide and carbon dioxide are minus 297.064 kilojoule and minus 394.55 kilojoule respectively. Now what they have also given is heat of combustion of carbon disulfide is minus 1109.18 kilojoule. Calculate the heat of formation of carbon disulfide. Is this point clear? So the required equation is so what do we have? The required equation is so calculate the heat of formation. So what does the definition say? Heat of formation means 1 mole of carbon disulfide liquid, it's in the liquid state, is formed from the elements in the standard state. So you have carbon plus 2s, sulfur, both are solid, and this delta H is what we have to calculate. What is the data given? The heat of formation of sulfur dioxide. So first equation, what do we have? Heat of formation means 1 mole of sulfur dioxide gas is formed from the elements in the standard state, S plus O2. So understanding the definition is very, very important. That's why I'm mentioning the definition again. You are given heat of formation, it means 1 mole is formed from the elements in the standard state. So this delta H value is sulfur dioxide is minus 297. So let's call this as delta H1, minus 297.064 kilojoule. The second equation that they have given is heat of formation of carbon. The next point is heat of formation of carbon dioxide. So what is the definition? 1 mole of carbon dioxide is formed from the elements in the standard state. So we have carbon, solid, oxygen, gas. So let's call this as delta H2 value. This delta H2 value is how much? Minus 394.55 kilojoule. Okay. Then we have the third one. They have given the heat of combustion of carbon disulfide. So carbon disulfide, when it burns in air or oxygen, it forms carbon dioxide plus sulfur dioxide. So if I make this as 2SO2, so what happens? How much this is? 2 plus 4, 6. So this is 3O2. Let's say this value, so I think it's balanced. So delta H3 will be equal to how much? It is minus 1109.18 kilojoule. So this is the values we have. I have converted all the statements into what? I have converted all the statements into equation. So now delta H, the value will be equal to what? Now listen, you need sulfur in the reactant. You have sulfur here in the reactant. You need 2 moles. Here there is only 1 mole. So 2 times delta H1. You need 1 mole of carbon in the reactant. You have 1 mole of carbon plus delta H2. Now you need carbon disulfide on the other side, that is product side, Laplace-Lavoisier law. So minus delta H3. I think you are by now familiar with what I am doing. Is this clear? So what happens is, I am doing by this method mainly for the board exam. Is this clear? So we have now equation number 4. What do we have? 2S plus 2O2 forms 2SO2. Then we have 5. What do we have? Fifth one. Carbon plus oxygen forms carbon dioxide. Then the 6th one. What do we have in the 6th one? It is reverse of the 3rd one. So what do we have? It is CO2 plus SO2 forms CS2 plus 3O2. So let us see what happens over here. See, 2 plus 1, 3, 3O2 gets cancelled with this. 2SO2, this should have been 2SO2, I'm sorry. CO2 plus 2SO2. So this 2SO2 and this 2SO2 gets cancelled. CO2 and CO2 gets cancelled. So what is the net reaction that is left? The net reaction is carbon solid plus 2S solid forms CS2 liquid, same as what is required. So now we do the same mathematical calculation over here. So what do we get? I think this time we can do it over here. So delta H is equal to 2 times 2 into minus 297.064 minus 394.55 plus 1109.18. So how much does it come to? So we have 297.064 into 2, 594 plus what do we have? 394.55. So this becomes 988.678. So this becomes this part minus 988.678 plus 1109.18. So this delta H value now will be equal to, so let's calculate. What do we get? We have 1109.18 minus 988.678. So that is 120.5 kilojoule. So this delta H is 120 plus 120.5 kilojoule. So this is our answer. I mean, the above sum can be even asked in an entrance examination, so I am doing it. I'll read it. This is a very simple sum, but sometimes just lack of understanding can create problem. Calculate the difference in heat change at constant pressure and at constant volume for the following reaction at 300 Kelvin. See, it's very simple. What they have asked is delta H we know is equal to delta U plus delta N RT. So they are simply asking delta H minus delta U is equal to delta N RT. They are asking you delta N RT. The problem is with delta N. See, delta N is number of moles of product in the gaseous state minus number of moles of reactant again in the gaseous state. This is where people go wrong. Where they go wrong is here H2. At room temperature H2O is liquid, means 298 Kelvin, H2O is liquid. People tend to write this as gas because they are thinking ethyl alcohol is burning, so water should become steam. At room temperature, that would be at standard condition, it will be liquid. So this 3 gets added up unnecessarily. So your delta N becomes, this is gas and this is gas. So 2 minus 3 is equal to minus 1. So your delta N RT will therefore be equal to minus 1 into 8.314 into 2, kitna 300. I'm sorry, into 300. So that will be equal to so that will be equal to 8.314 into 300. It's 2494.2. That means it's 2.494. It's minus sorry, minus 2494.2 joule, because R 8.314 joule per Kelvin per mole. So that will be equal to minus 2.4942 kilojoule. So this is what is the answer. So this small sum is actually has been asked many a times in what you call entrance exam. It's a very simple sum. I told you where people go wrong, calculating delta N. This can be a hassle actually. Okay. This is a very standard sum which is asked in many board exams, and repeatedly it has been asked. So what is this numerical about? Calculate the heat of combustion of benzene at 298 Kelvin given the heat of formation of benzene liquid, water liquid, carbon dioxide gas are these values respectively. So what do we have? What is given? One, heat of formation of benzene. So what is heat of formation ka definition? 1 mole of benzene C6H6 liquid is formed from the elements in the standard state. So we have delta H1 is equal to how much? It is plus 46.86 kilojoule. The second one that we have is heat of formation of water. What is heat of formation? 1 mole of water is formed from the elements in the standard state. So we have H2 gas plus half O2 gas. So this delta H2 value will be equal to minus 285.77 kilojoule. Then the third one is heat of formation of carbon dioxide. So again 1 mole of carbon dioxide gas is formed from the elements in the standard state. So delta H3 over here will be equal to how much? Will be minus 395.5 kilojoule. So we have converted the statement into equation form. We come to our usual way of doing it. What is it that we have? What is the required equation? The required equation is so calculate the heat of combustion of benzene. So what happens? Heat of combustion means 1 mole of benzene reacts with excess of oxygen of air, and all hydrocarbons, I told you, always when they burn they form carbon dioxide and water. So 6C, so 6 CO2, 3 H2O. So this becomes 15 by 2 O2 or 7.5 moles. Is this clear? 15 by 2 or 7.5 moles. Is this clear? So now what do we have? Delta H will be equal to, see, in the first sum you have got heat of formation of benzene. statement. Data. You need benzene here in the reactant side. So minus delta H1. In the second equation, you have hydrogen 1 mole, but you require how many moles? You have water over here. How many moles you require? 3 plus 3 times delta H2 plus what do we have? We require carbon dioxide in the product, we get it over here. But we require 6 moles, this is only 1 mole plus 6 times delta H3. So let us do the changeover and see if you are getting the required equation. So delta H, now this will be equation number 4 minus delta. So we get C6H6 liquid forms 6C solid plus 3H2 gas. Then the fifth equation, this is 3H2 plus 3 by 2 is O2 forms 3H2O liquid. Then the sixth one, what do we have? 6 times delta H3. So 6C plus 6O2 forms 6CO2 gas. So all the necessary changes have been done. So let us now see which are the ones which are getting cancelled. See over here, 3H2 and 3H2 is getting cancelled. 6C and 6C is getting cancelled. 6 plus 1.5, 7.5 moles of, oh, we need the oxygen. 6 plus 1.5, 3 by 2 is 1.5. So we get the required equation. C6H6 liquid plus 7.5 moles of oxygen gas forms 6CO2 gas plus 3H2O liquid. Are you understanding? So required equation is what we are getting. So let us do the same changeover with your delta H values. So therefore your delta H will be equal to, so this plus 46 becomes minus 46.86 plus 3 into minus 285.77 plus 6 into minus 395.5. So this is the value. In fact, this calculation is going to be easy. So what do we get? Minus 46.86 minus. So what do we have? 285.77 into 3. So this is minus 857.31 minus 395.5 into 6. So this is minus 2373 kilojoule. So now everything is minus, we simply have to add 2373 plus 857.31 plus 46.86. So this is, so delta H value therefore will be minus 3277.17 kilojoule.